Good morning friends. Now let us discuss about IDDQ testing. What is IDDQ testing? IDD is nothing but the current flowing from the power supply VDD. So on Q represents the quiescent state, that is when no input is given. IDDQ testing detects the faults by monitoring the value of IDDQ. And if there is no fault in the circuit, then the normal value of IDDQ will be around 10 power minus 9 amp. In case if any fault is detected, then the value of IDDQ will be greater than 10 power minus 5 amps. Next, what are the advantages of IDDQ testing? Normally the fault detection is easier when in this method. Then automatic test pattern generation is easier. The test pattern generation is very simple method, and the test length is also shorter. The testing time taken for testing is very shorter. Next, what is inductive fault analysis? The inductive fault analysis is nothing but it generates the realistic fault list, and it considers to generate the fault analysis, it considers circuit fabrication technology, defect statistics and physical layout. And here we can see the diagram where the defect spot is shown, and the defect is identified based on the distance between two conductors as well as the fabrication process and the size of the spot. Next, in a poly path, that is poly in the sense gate, polysilicon gate, suppose if any defect is there, the diagram, the first one shows without any defect. Diagram A, figure A shows without any defect in the poly path, and B represents in B the polysilicon, there is a defect in the polysilicon in the edges, and C represents the defect in polysilicon in the center, and D also the missing polysilicon in the center, whereas A shows without any defect in the polysilicon. Next comes the fault that can be detected using IDDQ method. These are the faults that can be detected using this IDDQ method, that is bridge and stuck-on fault, break faults. There are different type of break faults like a line break fault, gate break, drain and source break. We will see one by one. This diagram shows the stuck-on fault, that is if the input value, for example, if the output, whatever input is given, and suppose if the output is 2.5 volt, then the logic value for 2.5, it can be either 0 or logic 1, because normally 0 volt we consider it as logic 0, and if the output voltage is 5 volt, we will consider it as logic 1. Here if the output is 2.5 volt, then it can be considered either as 0 or 1. So the logic monitoring is inadequate because of this. So this is considered as stuck-on fault. Line break fault is, that is when the input signal, when the input line is not connected, if there is a disconnection in the input line, then this is considered as line break fault. Here the output IDDQ, the large current of IDDQ flows because of this. So because both the PMOS and NMOS transistors will be turned on due to this floating node. Next, gate break fault. When there is a disconnection in the gate input, this results as, this is considered as gate break fault. Here also when there is disconnection in the gate, the large IDDQ flows, and this can be detected, gate break can be detected if there is a, if the small current, conduction of small current for VDS greater than Thevenin, threshold voltage, and less than alpha minus VTH. And also in case of source or drain break fault, suppose there is any break in the source terminal or drain terminal, the intermediate voltage will rise so that the output large IDDQ flows, and this also is considered as source or drain break fault. And IDDQ can be detected under two conditions, that is normal IDDQ must be small, and a large IDDQ will be flowing if there is any fault. Thank you.